Today we're going to take one last look at absolute value inequalities. And in our next session, we're going to review for a test, since we have a half-chapter test midweek. So solving and graphing absolute value inequalities. If you recall from last week, there were two types, the less than or the and. Less nest in the middle, so when we graph those, the boundary points are shaded in the center. The greater than is the or type. Greater is the ors, and they will shade in opposite directions. So greater is more. Let's take a look at solving. When I see a greater than symbol, greater tells me it's an or, I am going to graph it. First, solve it before I graph it. I'm going to start with the x plus 4 is greater than 6, or, again, if I hear greater, or x plus 4, reverse and change the sign. Okay, so I will subtract 4 on both sides. I get x is greater than 2, or let's subtract 4 on the opposite simple inequality, and I get x is less than negative 10. So again, if I give you a blank number line, all you need to do is find your boundary points. So I see negative 2, and let's just say negative 2 is somewhere down, positive 2, I'm sorry, is somewhere down here. So if this is 2, open circle, and x is greater than 2, so everything will shade in this direction. Don't know if I have enough points, but let's check. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10 is right here. Open circle, and it says that x is less than negative 10. Ors will go in opposite directions. Greater is more, so or is more. Let's take a look at the second one. It's a less than nest in the center, so I'm going to have this 2x minus 5 nesting in between a 9 and a negative 9. It's a two-step, so I'm going to do two inverse operations. I'm going to add 5. Whatever I do in the center to isolate that variable, I must do on the left and the right. That'll give me negative 4 is less than 2x, which is less than 14. Let's divide everything by 2. And then I get negative 2 is less than x, which is less than 7. Now, in the past, we have written this as two separate ones, which tells us that x is greater than negative 2 and x is less than 7. So again, I find my negative 2. I find my 7. They're both open circles. And it says x is greater than negative 2 and less than 7. And this is where the solution lies. It nests in between those two boundary points. Third problem. Absolute value of x minus 7 is greater than or equal to 2. Greater is an or. So I'm going to have my x minus 7 is greater than or equal to 2, or my x minus 7 is less than or equal to, reverse the symbol and change the sign. Let's add 7 to both sides. This is a one-step. X is greater than or equal to 9, or let's add 7 again. X is less than or equal to 5. Let's find 5, and again, since there's no points, I can find my 5 anywhere. And there's 9. So it says that x is greater than or equal to 9, close circle and shading. into positive infinity. And then we have a closed circle at positive 5, and we're shading everything less than or equal to. So we're practicing what we learned about graphing simple inequalities and compound inequalities, and now we're changing it and applying it to absolute value. I'd like to do just one more problem. This one's slightly different, so let's pay attention to this details. All right, I have a less than. So less than is a nester, and it means that it's going to be an and. I'm going to have in the middle, nesting in between the two inequality symbols. And then I just put the -3 on the opposite side. Let's start by subtracting 1. That gives me -4 is less than -2x, which is less than 4. Now be very careful with this one because this is where I said we had to pay attention. I'm going to be dividing by a -2. What happens when we divide by a negative? It reverses the directions of our inequalities. So I get 2 is greater than x, which is greater than -2. What does that look like? X is less than 2, and, this is an and, x is greater than -2. Let's find -2 on our graph. And we'll find 2 on our graph. It's an and again, it says that x is less than 2, open circle, and it's greater than -2. And because it's an and, it shades in between, it nests in between. So here we remember that the absolute value equations for the and, the expression nests between the two inequality symbols that you see here, and then when we graph it, the nesting is in between the two boundary points. And that's all I'm going to review today for this. You'll do a little practice. Tomorrow we review for our test. Have a good day.